Nature's Resilience, Exploring Ecological Recovery in Secondary Succession After Hurricane Juan in Point Pleasant Park.
Introduction to Point Pleasant Park. According to Joachim, the park is located in the south end of Halifax, Nova Scotia, and it's about 75 hectares, which is about 130 football fields combined. The park serves as a major attraction for the locals as it has a beach and trails as well. As stated in Halifax Municipality website, the park served as a gathering place for the Mi'kmaq, the people native to Nova Scotia, and served as a British defensive site. According to Tolkien, the park is an Acadian forest which has red spruce, red maple, and red oak as its dominant tree species. According to Boyer, Hurricane Juan occurred on Monday, September the 29th of 2003. It was a second storm category with a wind speed up to 185 km per hour. The hurricane had a massive effect on the park as the park has lost about 70% of its canopy population as stated by Burley. According to Michael McDonald from CBC News, 8 people have lost their lives and it was responsible for about $192 million in insurable damage. The following definitions and terms are from the University of Chicago website by Max Rutinsky. So succession is a process where a natural biological community gets replaced over time. And there are two types of succession. The primary succession, and that's the creation of a new island and a new community on that island. For example, the creation of an island after a volcano eruption. And the secondary succession, and that's the restart of a community after a disturbance without the creation of a new island. A climax community is the equilibrium or the very end of a succession, and that could be changed by adding a disturbance. The following variables are going to be used to answer our questions. The results of the variables are uploaded on Brightspace. The objective is to observe how a Canadian forest community has changed from 2003 to 2022. Also, to analyze both the changes of the dominant species and the changes of the community metrics in the same period of time. Our hypotheses are as following. The total density will increase over time. The average diameter at breast height will increase, but will not be as high as pre-hurricane. The dominant species density will increase over time. Both species richness and density will increase over time, while species evenness will decrease.
For this study, 6 sites were chosen based on where the hurricane caused the most extensive disturbance to forest structures in the park. As illustrated in Figure 1, we can see that the most disturbed areas were located on the southeastern side at south-facing low elevation. This is primarily thought to be due to the southern direction of Hurricane Juan. The proximity of damage suggests that winds created a major canopy loss, which led to random distribution of disturbed patches. This information came from Burley et al. 2008. All data was collected by Dalhousie students enrolled in BIOL2060 in any one of the 6 surveyed sites under supervision of a lab instructor. Students identified trees to the nearest species and used a measuring tape to measure all living trees greater than or equal to 2.5 centimeters in diameter at breast height, also known as DBH. This is a standard method used to calculate the trunk diameter of a tree and is measured at approximately 4 feet or 1.3 meters from the ground. This information came from Forest Inventory 2021. All of the graphs and linear regression analyses were conducted using data in the same plots every year from 2004 to 2023, with a few years where data could not be collected. These years include 2005 because of Hurricane Ophelia, 2007 due to Hurricane Noel, 2016 due to Hurricane Matthew, and 2020 due to the COVID-19 pandemic. This data was then used to analyze the density of tree species in their sites per 400 meters squared, and the community metrics recorded in this study are as follows. Total or species-specific density per 400 meters squared, species richness portrayed by S in equations, evenness portrayed by J, dBH in centimeters, and dBH and species name of all species equaling or above 2.5 centimeters. The Shannon Diversity Index is essentially a measure of diversity at different levels. It considers number of species, or richness, as well as evenness, portrayed by J. This comes from Konopinski 2020. This is an important metric as it lets us visualize changes in the forest ecosystems in the park over time and how density, species evenness, richness, and diversity have changed alongside ecological succession. Linear regression analyses were used for this study as they allow us to visualize the relationship, whether it be positive or negative, between the dependent variables and time. Schneider et al. 2010. This index also allows us to calculate richness and evenness using density. The equation shown below, or above my head, with the sideways M symbol means the sum of values. The values included in this equation are S, the number of different species, Pi, proportion of a species abundance relative to the total abundance of all species in the community. Another study was conducted in the same area as this one, which analyzed the density distribution of coniferous tree species in Point Pleasant Park as shown in Figure 2. I included this as I feel it could help us visualize the results of our study on succession, given that the test factors of both studies are relatively similar. This data was collected in the winter of 2006 to 2007, approximately 3 years after the hurricane. As we can see, there are many patches of forest with all tree species combined to show that the sections of greater than 40 trees are dominating here. This may help us predict future metrics and changes in the forest sites over time.
The total density of trees in Point Pleasant Park has increased in the years following the hurricane, giving the graph a positive slope of 9.9554 and a positive trend line. The average total density in 2004 was close to 0 trees per 400 meters squared, while the average total density in 2022 had increased to approximately 150 trees per 400 meters squared. Prior to the hurricane, Point Pleasant Park was an even-age old-growth evergreen forest. Therefore, there was a lack of young trees to decrease the winds or to start to grow after the older trees were torn down. Then, 70% of the forest was torn down by the hurricane. Thus, we see very low density directly following the hurricane. And as new trees start to grow and the forest starts to recover, density gradually increases. This is an example of secondary succession. The destruction of the even-age old-growth trees in Point Pleasant was followed by the growth of early successional, shade-intolerant pioneer species of trees, which were able to take advantage of the increased resources available for them. Burley et al. 2008. Due to the growth of these first pioneer species, and more trees as the years progressed, total tree density has increased following the hurricane. As the forest moves towards its climax community, we can expect to see total density increasing even more. But once the forest reaches its climax community, we can expect to see the density level off. As seen in Figure 2, the diameter or breast height of the trees measured in all 6 sites in Point Pleasant Park has decreased following the destruction of the 2003 hurricane. This is proven by the negative slope of the line of best fit for the graph, negative 0.4854. The average DBH measured in 2022 was approximately 3 centimeters, which is significantly smaller than the average DBH measured pre-storm, which was approximately 12.5 centimeters. This, too, can be explained by secondary succession. The removal of the old-growth tree canopy due to the hurricane cleared a space in soil previously occupied by those larger trees that could then be occupied by newer, younger trees. This decrease in DBH can be directly attributed to the increase in growth of smaller trees springing up in the aftermath of the larger trees being torn down by the storm. It can also be attributed to a change in dominant species. Prior to Hurricane Juan in 2003, the dominant species of trees were large evergreen trees such as red spruces with an average DBH of 61 centimeters. Hurricane Juan tore these large evergreen trees down. Now, post-hurricane, the dominant tree species are smaller, such as red maples, with an average DBH of 14 centimeters, significantly smaller. Both replanting efforts by the municipality as well as faster growth rate of these types of trees have contributed to the shift in dominant species pre- and post-storm. As the form moves towards its climax community, we can expect to see an increase in average DBH as the young trees that grew in after the hurricane grow a bit bigger. However, average DBH likely won't return to pre-hurricane conditions because the average DBH for the dominant tree species post-hurricane is significantly smaller than before the storm. Nevertheless, it will reach a stable equilibrium as the forest moves towards climax community.
Figure 5 shows a red spruce density in which it had increased over time. Density was significantly higher in 2023 than in 2004 in 4 different sites. Figure 6 shows the red maple density with a better linear slope, and it shows a positive increase. No maple trees were observed in 2004, while they were found in 4 different sites in 2023. According to Burley, the park was dominated by red spruce and red maple before the hurricane, which are native to the park, and the result shows a sign of natural regeneration of native species. Figure 5 shows that the red spruce density hasn't changed drastically from 2014 to 2023, which might indicate that it's getting closer to the carrying capacity or the climax community. And the same goes for the red maple from 2015 to 2023, according to Figure 6. We can predict that both species will keep increasing until they reach their carrying capacity or climax community due to lack of space or resources.
A climax community refers to a community whose ideal endpoint consists of populations that remain stable and in balance with the environment. Pandolfi, 2008. As shown in Figure 7, total richness has increased in the park over time, as indicated by the positive trend line. This tells us that there has been a significant positive increase in species richness over time, indicating that species diversity has begun to replenish within the park. The closer the R-squared value is to 1, the more the points are explained by the trend line. Here, our R-squared value is 0.64, indicating a mildly strong correlation. According to Steenberg and Duinker, it is estimated that Hurricane Juan caused the fall of approximately 80% or 75,000 trees in the park, which is a significant number. The higher R-squared value for succession indicates richness and regeneration occurred across multiple species as diversity increased across a large range. As the forest begins to approach its climax community, we might eventually expect to see richness begin to decrease as the community reaches its carrying capacity. George's, 2001. As we learned in our class, carrying capacity refers to the maximum population that a community can support. Following a rapid growth period towards the carrying capacity, resources may begin to become scarce, and the community will be less able to support the full population. This essentially means that there will be less of an opportunity for the species to establish itself. I am going to be starting off our reflection question section with question 1. Question 1 is as follows. It is noted in the presentation that 6 study sites were from the areas where the park experienced the most significant disturbance from the hurricane. If the same research was conducted on the areas least disturbed by the hurricane, how do you think the forest ecology would differ? Would evidence of secondary succession appear later in the years, if at all? So there would still be disturbance in the park areas, though they may not be as bad. Evidence of secondary succession would most likely still exist given that the storm severely impacted the whole forest. Approximately 80% of the trees were felled, as mentioned previously. Depending on where these sites are, the damage may not be as severe due to the southern direction of the storm. Burley et al. 2008. We may, however, expect to see a greater proportion of larger trees, or trees with a larger diameter, that did not get knocked down by the hurricane in the northern part of the park as opposed to the southern one. Coming back to this image that I mentioned in the methods section featuring a different but similar study in the park, it appears as though area not directly on the southern tip of the park had greater tree density after 3 to 4 years following the storm, whereas sites closest to the water had fewer trees after the same amount of time, as seen in Figure 8. This suggests that disturbance may have been less severe in the northern parts of the park away from the water.
Yes, I do believe that this approach by the government to engineer an ecosystem with a higher concentration of trees that are less susceptible to storms and higher winds will be successful. On the other hand, this is not a simple yes or no question. Because of climate change, we can expect to see bigger and more destructive storms, including hurricanes, farther north and around the Halifax area. Therefore, just selectively diversifying Point Pleasant Park and planting trees better able to tolerate high winds is not necessarily enough to keep the park from future destruction. Nevertheless, with the efforts of the government to diversify the forest of Point Pleasant Park and plant trees better able to tolerate high winds and storms, like planting red maple trees versus trees like red spruces, which aren't very good at tolerating high winds. With this, we aren't likely to see damage on the same level as what was inflicted by Hurricane Juan, and we are likely to see this new Point Pleasant Park ecosystem succeed. Yet, this doesn't mean that the forest in Point Pleasant Park is now invincible to the weather. It is just better able to cope now, thanks to the efforts of the city.
According to Kevin Keyes, non-tree species like brackens could dominate early communities after the hurricane, which might provide nutrients to later trees as shown by Turchin. Also, trees increase as the ground flora decrease as shown by Turchin. Furthermore, the microbes increase nitrate level in soil as stated by Burley, which helps trees to grow. However, non-tree species could also affect the growth of tree seedlings by competing with them for resources and light, as they could tolerate a range of soil and light conditions, so they could recover rapidly after a disturbance. In the end, non-tree species have both positive and negative effects on trees.
Hurricane Juan initiated secondary succession in Point Pleasant Park by removing the old-growth tree canopy and providing resources, space, and light for new younger trees to grow. We predict that the Acadian forest in Point Pleasant Park is currently in an early/mid-successional stage. 3/4 of the forested area of the park, 45.8 hectares, were still classified as immature in growth level in 2018. Succession in Point Pleasant Park has been heavily influenced by the fact that this is an urban park. When replanting, creating a forest more resistant to environmental change was prioritized, as opposed to returning the forest to its pre-hurricane conditions, thus changing the dominant species in the park and the entire ecology of the park. Indigenous ecological perspectives prioritize focusing on the development of a more natural forest ecosystem, closer in resemblance to the pre-hurricane community in Point Pleasant Park. This approach would mean the renewal of native plant species rather than replanting of new trees that are more resilient to environmental fluctuations. This approach is more in tune with the priorities of all species living in the park, and not just humans, where our priority was making the trees in the park more resistant to change for our own benefit. Point Pleasant Park has proven to be capable of secondary succession, but the ecology of the park is now dramatically different from pre-hurricane conditions. Thank you to the BIOL2060 teaching team, Emily Caddis, Robert Latta, and Dr. Alison Schmidt, without whom this work would not have been possible. Dalhousie University is located in Mi'kma'ki, the ancestral and unceded territory of the Mi'kmaq. We are all treaty people.